Hello, welcome to this discussion related to IS 13920 draft documents, part 1 and part 2. So we had a network issue yesterday when we arranged the session. So what I've done, I have recorded, the entire version here quickly again so that, I can capture the important points and you can quickly go through these documents. Now, as we discussed yesterday also, that still I'm going through this documents. But what I'll do in this session, I'll go ahead and I'll highlight few of the important points, which I've just noticed, and I'll share my quick observations on that, or let's say my quick comments on that, based on my understanding, right? And I'll encourage all of you to please share your comments to the BIS Technical Committee for all major and minor points, whatever you find in the documents before 3rd August 2024, so that appropriate modification may be done in the published standard. And it's very important because once any standard is published, then it becomes really very difficult, to get it to modified. It takes a number of years altogether. So whatever major or minor points which you find in part 1 and part 2 must be sent to BIS Technical Committee before the due date. So that's one purpose of this session, wherein I'll just give quick view about, let's say, my understanding of let's say these documents. Okay, so let's get started, and just let me share the screen. So as we know that now IS 13920 is now divided into, or rather will be divided rather into 11 number of parts. And part 1 is a general document, which will be applicable to all kinds of buildings. And the buildings starting, or let's say parts which are starting from, let's say, part number 2. So part 2 is exclusively for or focusing on the buildings. And the remaining parts, part 3 to 11, those are focusing on, let's say, liquid retaining tanks, bridges and retaining walls, industrial structures, base isolated buildings, pipelines, etc. So these are a few more parts which we'll see, which we'll see in the near future, right? Okay, but right now, the documents, draft documents, which are released as a part 1, that is a general document applicable to all types of buildings, and part 2 is specifically applicable to the buildings. And in the part 2, as you must have gone through that now, in the part 2, masonry, RCC building, as well as steel structure, all 3 types of materials are now added in a single part. Okay, so. Okay, that's what it is said, that the provisions for masonry, reinforced concrete, and steel buildings are now specified separately. These are the changes as mentioned in the forward, that in the IS 13920 part 2, the provisions on buildings have been harmonized from the relevant provisions as given in IS 4326, 1905, SP7, and 16890. Additional criteria for masonry structures are added. Additional criteria for concrete structure is added. And it states that the admissibility of different structural systems in the earthquake zone is now clarified. That's what it is said. The structural plant density of the structural walls is varied with the earthquake zone and category of the building. Somehow I could not locate this specific paragraph while I was quickly going through the document. Let's say if you have noticed, then please mention it in the chat box below. That what is the exact paragraph or clause number where this structural plant density of the structural walls is mentioned, with reference to earthquake zone. Because that was one of the practical difficulty which we had, like when we provide, or rather whenever structural wall is required. So it was required to be provided as a 2% in each principal plant direction. Now here it is saying that it is varied with reference to earthquake zone, but I could not locate that specific clause. For the steel structure, as I understand, the IS 18168 2023 is reproduced. I think majority of the clauses or provisions are reproduced in the criteria for steel structures. Of course, I have not compared clause to clause, but quickly by just going through the different clauses, I could see that majority of the clauses, I think, are reproduced from that document. So it's not actually new provisions. It is already the standard which is published according to me. So the same standard is copied, we can say, or reproduced. For the steel structure also, it is said that the structural plan density of the structural wall is varied with the earthquake zone and category of the building. Now, generally, the steel structures, this requirement may not be applicable, which is the structural plan density, because generally in the steel structures, let's say we provide bracing, or let's say moment resisting frame. But I could not locate this again specific paragraph with reference to this requirement, or let's say with reference to this point. So if you have noticed, you can mention this in the below chat box. Yeah, these are the certain standards taken as a reference while preparing this draft document. So this standard, the part 1, is applicable to all types of structures. We can say it's a general document. So it is providing guidance to enhance earthquake resistance of members and structures, use of base isolators and supplemental damping devices when buildings are designed to sustain limited damage. It is now talking about base isolators as well as supplemental damping devices in a brief in this part. Perform capacity design of structural members and connections. There is a clause for the capacity design of members, which is included in this document. When buildings are designed to sustain damage and to mitigate effects of liquefaction. For liquefaction, also few clauses are added in this document. And in this part 1, the reference is given everywhere of IS 1893 draft code, which was, let's say, CD 39-22345. So this still, it has not become public as a published standard. So the reference is given in this entire document to the draft code of IS 1893 part 1, which was released before a few months. As it is said that the use of some of these building systems has been restricted in the higher earthquake zone. So those are described in this standard. So wherever, let's say, if you find kind of a practical difficulty, then definitely you must write your observations on that particular structural system, which is restricted, let's say, in the standard. The member capacity is a new requirement which is added. What is said here that to resist the expected earthquake shaking at the site of the structure, the members, the joints between the members and the connections between the members of the structural system shall be designed so that the stiffness of a member is such that it produces the predefined ductile actions within it. The members are proportioned such that their relative strength of members meeting at joint ensure that designated members alone sustain inelastic effects. Then individual strengths associated with brittle actions of each member are such that these brittle modes of failure do not occur before the pre-identified ductile actions, which are, let's say, fully realized. And the individual strength associated with this predefined ductile actions are realized at least up to the levels of deformation of ductility demand at the said predetermined locations. So what it is trying to say that it's actually talking about the desired collapse mechanism. So whatever collapse mechanism we have intended, or let's say which is appropriate, so that needs to be ensured. So according to me, to ensure this clause or to meet this requirement, we will have to go for advanced analysis, like let's say non-linear analysis. According to me, this requirement may be further elaborated with very specific requirements. And let's say if when we go to the part 2, for example, let's say if we are following all requirements of part 2, so by default this requirement is satisfied, or additionally we need to meet this requirement. That is one of the question what I have. Meaning, if we are following all the clauses of part 2, then again, in addition to that, is it required to ensure requirements of this paragraph? If it is required to ensure requirements of this paragraph in addition to the part 2, then non-linear analysis will be required for all buildings type of structures. So I think that's where more clarification is required, according to me, for this paragraph, which is the member capacity. The next part, it is said that all the joints between the members and the connections between the members shall remain elastic, even when the adjoining members sustain inelastic actions, so that the connections shall not become a weak link in the entire structure. That is the intent of this draft document. So even if adjoining members are sustain inelastic actions, the connections shall remain elastic. So for that, the higher factor of safety must be utilized for the connection design. Right? So now here, more specific, details may be added. Again, the same question what I have, like, do we have to perform separate analysis or separate design for ensuring all these requirements? Or let's say if I follow part 2 in totality, then this is automatically considered. In the next paragraph, the structure capacity is identified. And here it says that a minimum overall lateral stiffness to ensure that the overall lateral drift demand on the AUs appended to the SEs is not too large to damage the AUs. Now here it says not too large, so that AUs, which is let's say architectural, what's the full form? Let's see the full form of AU. I just forgot. The full form of AU is architectural, element, and utilities. Okay, E stands for element. So architectural, element, and utilities. So the overall lateral drift demand on the AUs appended to the SAs not too large, so that AUs should not sustain any kind of damage, or rather they should be able to sustain the demand which is imposed on them when they are appended to the SAs. Now here again I think more specific detail would be required, like what is the specific limit up to which we can consider. Now that will again vary from AU to AU, right? For different type of AU, different requirements will be there. So what is that specific limit that will be required to ensure or let's say for implementing this clause, right? Here also it says a guaranteed overall lateral strength to ensure that the lateral displacement ductility demand on the structure is not unduly large. So here a few statements are made as a general statement. So again, I have a same point that I think one more paragraph could be added, that the specific requirements will be mentioned in the relevant part, which is let's say part number 2 to part 11. So wherever it is applicable, or the detailed requirements will be mentioned in the separate parts, part 2 to part 11, because different AEUs will have different limits which we need to adhere. So So maybe, there's everything, all clauses which are written here, the mathematical limit, or let's say very specific requirements, may be addressed in the relevant parts. I think that may be added here. Earthquake resistant design. So okay, for that, the structure can be designed to resist effects of earthquake shaking with low damage in the structural elements, or let's say damage in the structural elements. So there are two concepts. Now, no member of the lateral load resisting system shall sustain damage under the effects design earthquake shaking. So first of all, what is low damage in the structural elements? So only specially designed devices which are, let's say, placed at selected locations shall dissipate the earthquake shaking energy input to the structure. So in that case, there will be low damage in the structural elements whenever we have specially designed devices which are again placed at a selected locations, right? And the energy dissipated devices are, let's say, for example, base isolators, supplemental damping devices. So those are all our energy dissipation devices, we can say, or these are the devices in which energy will be dissipated during seismic event. Base isolator shall be designed as per requirements of IS 1893 part 6. And a supplemental damping device, of course, we need to refer specialist literatures. Generally, we will be doing this, which is damage in the structural elements. For the damage in structural elements, there is a concept added, which is the capacity design. It says that the members identified to sustain damage shall dissipate the earthquake shaking energy input to the structure at predetermined locations in them. So the locations which we predetermined, at those locations, member will sustain damage or shall dissipate the earthquake shaking energy. Second is through ductile actions induced in them without inflicting any damage in the joints and connections. So here again, the same point which I will just try to make, that if we follow all provisions of part 2, then we need not, again, ensure this requirement. So that means by default, this requirement will be satisfied. That's what, let's say, I understand. But that paragraph should be written here, according to me, everywhere, wherever, let's say, this requirement is specifically addressed in detail in the relevant parts. Right? Relative strength between members. Sorry, relative stiffness strength between the members. So let's say by ensuring higher demand to capacity ratio of the bending moment, and let's say relatively lower bending strength, which is let's say kind of strong column weak beam concept, which we are considering in the as per the published standard. Relative strength within a member. So when a member is identified to sustain damage during earthquake shaking, the ductile action shall be ensured by precluding the brittle modes of failure do not occur before the ductile mode of failure, right? So brittle mode shall not occur before the ductile mode, and ensuring that the ductile mode of failure to be tension governing type. Now this, I think this may require, a few more clarification. What is the meaning of tension governing type? So the failure which is attributed is for the is let's say to the tension governing type. So is it for any specific type of material or for, let's say, all type of material? I think few more clarification is required for this line, according to me. The ductility of a structure shall be enhanced by improving the ductility of materials, sections, and members. Masonry structures providing vertical steel reinforcement bars in grouted cavities and horizontal steel reinforcement bars as joint reinforcement in walls and wall piers to resist tension actions. Then providing vertical and horizontal RC bends in masonry walls to confine the wall and reduce the masonry panel size. These are the way we can increase ductility in the masonry structure. In concrete structures, by confining the concrete through closely spaced closed loop transverse reinforcement embedded in concrete and choosing sections with the larger cross sections area for the columns. So we always see that always there is a requirement of increase in the column size when we refer provisions of IS 13920. For the steel structures, choosing structural sections with the smaller B by T and D by T ratios, and choosing sections with larger cross-sectional area to reduce axial stress and small LE by R ratios to prevent local and member buckling. These are the ways by which we can increase the ductility. So with this, we can say in a brief, what I can say here that with this requirement, the cross sections which we are considering as per IS 800/2007, those requirements will be relatively more stringent as per this draft document, because it is requiring, or it is suggesting to consider smaller B by T and D by T ratio. It is also suggesting to increase let's say, or rather it is suggesting to reduce the slenderness ratio, right, to prevent the local buckling. So the cross-section size is what we are considering as per IS 800/2007 will actually increase as per this draft document, and I think significant increase would be there. The connections we discussed, just before that, shall be designed to remain elastic when the designated members sustain ductile damage at the predetermined locations. So for the concrete structures, ensuring sufficient anchorage and development length of the longitudinal bars, that's the by way we can make the connections elastic, and using mechanical couplers to splice longitudinal bars. And of course, no welding is permitted. That's good statement which is made in document. So now it is made very clear that welding is not permitted. Welding of reinforcement is not permitted for the, as far as earthquake resistant design is concerned. For steel structure, reinforcing the connections at joint regions and using HSFG bolts when adopting bolting. So HSFG stands for high strength friction grip bolts. So of course we discussed about this HSFG bolt at a greater length in past few sessions, and it is of course it brings few practical difficulties. Of course, in a smaller to the medium scale project, of course, in a large scale project, HSFG bolts can be adopted. But here it says that SHFG bolt to be considered for steel structures, and of course, reinforcing the connections at the joint region. These are the way by which we can make the connections elastic. Geotechnical aspects are added in this document, and always this is one of the comment in all earthquake resistant design draft documents, that it is better that we place these geotechnical aspects in the relevant geotechnical investigation standards, meaning so that what I mean to say that, for example, here the paragraph is written for the liquefaction that it shall be ensured that the site has a factor of safety against earthquake induced liquefaction of at least 1.4. Now here again in the CD 22343, again I just made same comment here from my side, that it's better that all the geotechnical related, investigation related, or geotechnical engineering related aspects must be considered in the relevant Indian standard, which are focusing on the geotechnical engineering, according to me. And why I'm suggesting this, because it may create a potential conflict, and let's say geotechnical engineer may or may not refer the standard, for the earthquake resistant design. So I think that would be better approach to add or rather to modify the Indian standard of geotechnical investigation, and then the appropriate reference can be given to the relevant geotechnical investigation standards. Okay, so there are a few clauses added for the liquefaction, and it's also talking about measure to reduce, or let's say measure to mitigate the liquefaction at a site. So there are certain measures to reduce the demand on soil layers by stone columns and piles. Of course, it's just only the means which is written, but now again it requires a very detailed and elaborated procedure to adopt, let's say, certain technique on the real project, and add measures to increase the capacity of soil layers, which is vibro compaction, vibro replacement, and surcharge. Susceptibility to landslides. So for the landslides, also a few paragraphs are written here, and it says the techniques are mentioned as a soil nailing, retaining walls, ground anchor walls, horizontal drains, strengthening with the geotextiles, etc. Okay, in the last part of the document, which is para number 8, that's the miscellaneous items. And here it is talking about architectural elements and utilities, which is AEUs. So here different strategies are included for protection of AEU. So as we can see that that shall be protected by strategies. So there are different strategies. So let us see what are the different strategies added here. So first of all, earthquake protection strategy. All AEUs. Now again, see, if you have referred this draft document CD 392234, here it is identifying the requirements of AEU in much more detail. So here reference is given to the draft code IS 1893, and what it says that all AEUs, whether it is in new or let's say in the existing structure, shall be protected against the effect which is mentioned in para number 8.2 of CD 392233, and connection system shall be adopted to anchor AEU such that the acceleration sensitive AEUs, so all AEUs are classified in two categories. We can say one is the acceleration sensitive AEUs which are sensitive to the acceleration, and AEUs which are sensitive to the displacement. So if they are sensitive to the acceleration, then they are held against, let's say, overrunning, sliding, or both. And if those are displacement sensitive AEUs, then they are released at one of their two ends to offer no restraint to likely relative deformation. And it says that the AEUs shall not be secured to the infill masonry walls provided in concrete or steel buildings. So maybe it may be because the infill masonry walls is likely to sustain a certain amount of damage during seismic events, and then that may damage AEUs. So it says that AEUs shall not be secured to the infill masonry. Then there is a non-engineered protection to secure small, light, and loose object, let's say like books, groceries, crockery, cutlery, etc., bottles, which cannot be held individually and connected to the structural elements. The AUs shall be contained within an enclosure, which is, let's say, latched, tied back to stay within the enclosure, and held in the cabinet or shelf itself, which itself is protecting by securing it to the SEs as per the requirements of the standard. So that these all are called as a non-engineered protection. The next is the pre-engineered protection. In the pre-engineered protection, the vendor or the manufacturer will design the fastening system, and then they will provide those fastening system along with, let's say, specifying the locations. For example, if we see quickly this requirement, let's say cupboard rested against wall, or let's say completely kept away from them. Small bookshelves, refrigerators, wall-mounted objects, tabletop TVs, computers, laptop. On the tabletops, shelves, outdoor and indoor AC units, filling cabinets, sideboards, electrical wires, plumbing pipe, etc. So many items are given here for a reference. So what it said here, the manufacturer shall provide the pre-designed anchors along with the shipment of the AEU. So the anchors will come along with the AEU as a pre-designed anchors, and instructions to fix the anchors at predetermined locations of AEUs. The manufacturers shall foresee all possible on-site conditions before setting prescriptive standards for securing AEUs. So here the responsibility will be with the manufacturer or the vendor to design and then to supply the anchors. And that will be considered as a pre-engineered protection. The last is engineered design protection, or let's say, yeah, we can say it as an engineered design protection. So that is applicable to the AEUs, which are kind of, let's say, massive or very long objects. So example is, let's say, cable tray, and let's say turbo generator. Those are very, of course, turbo generator is very, very massive. Cable tray, we can say it's a very long object. So for that, it is suggested that we shall adopt engineered design protection. So here we can see that the AUs shall be secured with custom-made connection system to the ACs. Custom-made, that means those connections needs to be designed, right? And the anchors required for securing the AUs at the site of the structure shall be designed and provided at design locations. So for this kind of elements, that will be specific requirements, or rather this kind of elements shall be designed separately, right? So these are the strategies which are added for the AUs. Now, design to protect AUs, the earthquake demands on AUs identified for pre-engineered protection and engineered design protection shall be estimated as per para number 8.4 of CED 39-22343. In the subsequent paragraph, it is talking about consideration of AU in the critical, or let's say, lifeline structures. So what it says here, that AUs shall be given special attention if they are part of critical and lifeline structures, which are, let's say, required to be functional and operational immediately after the earthquake. So all the AUs shall be functional. Then and then the hospital, or let's say such critical structure would be, under operational stage. So for that purpose, the stringent requirements are defined here specifically for the AEUs. So what it said, that the following AEUs shall be prohibited in such structures. So false ceiling hung from the soffit of RC floor is prohibited. Tiles pasted on floors, unreinforced load-bearing masonry walls prohibited. Facade made of stone, ceramic glass prohibited. Any AU nailed to or supported by the unreinforced masonry infill walls is prohibited. Any duct and piping system part of air conditioning system shall not be anchored directly to the floor slab. The false ceiling shall be used only sparingly in the hospital and critical buildings. And the provisions are given here that if, first of all, false ceiling should be avoided as far as possible. But if it is used, then how it should be connected. So those clauses are given here. For the structural glazing also, it is said that the structural glazing shall be avoided in the hospital buildings. And let's say if it is required to be used, then there are very stringent requirements are identified here. That glazing is required to design to sustain the lateral drift, which is R times delta. And also it is suggesting to carry out full-scale experimental testing under the effects of expected strong earthquake shaking, because glazing is vulnerable element during extreme seismic events. So it is said that that shall be avoided in the hospital buildings. And in the last part of this document, it is suggesting the separation of adjoining buildings. So a few details are given for the separation, wherein, let's say, for concrete walls, just we can see here, there is a sheet metal flashing added on the top. Okay, and here we can see this is the metal flashing. Right. So likewise, few details are given here for the adjoining buildings. So this is about part one of the document. Okay. Okay, now let us see quickly part two. So part two, as we just discussed, it is now talking about masonry structures, concrete structures, as well as steel structures. And that's why it is running in 132 pages. This standard provide additional provisions for earthquake resistant design and detailing applicable to all buildings. So this we have seen already. We can, okay. So here it says that for the cold form light gauge steel structure members shall not be used as a part of the earthquake load resisting system. Okay, so we cannot use the cold form light gauge members. This is the statement which is made in this part. For the reinforced concrete buildings, these are the different frames or systems which we are providing. Right. Again, we can see everywhere the reference is given to the CD 3922343, which is again a draft document. It is not published yet. Provisions of this standard shall be adopted in structural systems of steel buildings as admissible in different earthquake zones as per table 11 of CD 39. Of course, so there were a few comments which I made with reference to this part regarding, let's say, admissible, or let's say regarding limitation of certain structural system in the higher seismic zone. And that we discussed, while talking about IS 1893 draft document. Okay. These are the two couple of new definitions. Capacity design. So capacity design, the design process beyond those in the basic design of non-yielding structural elements, members and connections, which consider the effects of inelasticity incurred in yielding members, resulting in overstrength based demands on the non-yielding structural elements. So there's a new definition added, capacity design. Now it's the same concept, the capacity design, which is added in the part one. So the same definition is mentioned here. And the capacity protected element, these are the members which are designed to remain elastic using capacity design principles when an adjacent member is undergoing inelastic straining during design earthquake shaking. So these are those are considered as a capacity protected element. Curvature ductility, the ratio of the curvature at the ultimate deformability of the section and that at first flexural yield in the section. Cross tie hoop structural wall is, of course, a plate-like vertical member of a building which resists the axial load and bending moment and shear force. Now here, this is the new requirement. When the bending moment diagram of the vertical member about its major axis or minor axis along the height changes sign within each story, then it shall be treated like a column. So earlier, or rather in the published standard, right now we have the demarcation between column and a structural wall, or let's say, or a shear wall, with reference to aspect ratio, or with reference to, let's say, plan dimension of the element, which is, let's say, 4 times depth. Or we can say if depth is greater than 4 times width of the section, then we consider it as a, let's say, a shear wall, right? So now that requirement is removed from this draft document, and now it is said that based on the nature of the bending moment diagram, we will have to take a call whether our element can be classified as a structural wall or as a column. Same thing is described in the later part of the document. We'll see that paragraph also when we go to that portion. For the steel building, demand critical weld is nothing but a weld which is connecting two structural components and which are part of lateral load resisting system, and at least one of which is expected to undergo inelastic straining following yielding. So the weld which is connecting, let's say, two structural components, and which is, let's say, part of lateral load resisting system, and out of which if one of the component is likely to go under inelastic straining, then that welding will be considered as a demand critical weld. Of course, so there will be stringent requirements for design of such type of weld. Eccentrically braced frame, of course, I have talked about these frames several times when the draft document was published for the ductile detailing of steel structures, and I have made several comments on this. So same thing is now reproduced here in the in this document. So my comments remain same on EBF. Material strength uncertainty factor is added for the steel structures. It's the same thing, same concept of IS 18168 2023. Okay, so let's directly go to the concrete structure, because still I am in process of going through this requirements for the brick masonry. Let's jump to the page number 67. Let's see. Okay, so let's try to find out from where it starts. Okay. Let's start with the requirement for the reinforced concrete buildings. Okay, these are some same documents are here. Okay, it says that for beams which are meant to undergo flexural, or let's say plastic hinges during strong earthquake shaking, shall have slenderness ratio in range of 12 to 14. So where LC is the clear span of the beam, and D is the depth of the beam. So, so at the locations of plastic hinges, this slenderness ratio shall be restricted in this range of 12 to 14. And beams with the smaller LC by D ratio, let's say like transfer girder and deep beam, so those shall be designed as per the provisions of 12.2.3. Now, what is this provision? 12.2.3. If we just go here, yeah, 12.2.3 In the estimation of area of transverse reinforcement, the grade of transverse steel shall be taken as 415 MPa, even though the grades of steel is used is 500 MPa or 550 MPa. So, this is the only requirement which is to be satisfied. I think that more clarification may be required here, specifically for the transfer girders and deep beams. But as it is mentioned, we at least we need to follow this requirement 12.2.3. This is the design shear capacity. Now, as it is in the published standard here, also it is said that the uncorrect concrete in the cross section shall not be considered for while we are calculating the or while we are checking the shear capacity. This is okay. Okay, this is a minor change. Now it says that the 75% of the steel on its top face shall be provided in beams that are part of the lateral load resisting system, obviously, and 50% of the steel on the top face to be provided. These are splicing requirements. And transverse reinforcement, it is same. The design axial force and bending moment capacity, the axial force capacity and bending moment capacity of a beam at the critical section shall be estimated considering PM interaction. So the design shear force is okay. Okay, concrete shall be considered to carry no shear when the member is in tension. So if a column is under axial tension, so in that case, the concrete portion shall be ignored for for consideration or for calculation of shear capacity. Column to beam strength ratio remains same, so there is no relaxation. It is 1.4 times to be provided. Strong column, weak beam concept here. The ductile detailing is okay. I think almost the clauses are almost same, I think. Okay, when the calculated point of counterflexure under the effect of gravity and earthquake effects is not within the middle half of the member or clear height, the special confining reinforcement shall be provided over the full height of the column. I think this clause is also there in the published standard. Right. The structural wall, for the structural walls, few specific requirements are added here. So now it is not said as a shear wall, it is said as a structural walls in this standard. First of all, it is identifying the requirements of minimum thickness. So minimum thickness is 200 mm for buildings with beams not framing into the wall along the direction perpendicular to the minor axis. If there is no beam which is framing, let's say from the minor direction, then the minimum thickness is 200 mm, which we have to consider. If there is a beam which is framing from the minor direction, then thickness requirement is 20 dB, minimum 20 dB for buildings with beams framing into the wall along the direction perpendicular to the minor axis at a location where, and again, the beam can be provided at a location where there is a boundary element. So it becomes 20 dB. And the last requirement is 300 mm for buildings with coupled structural walls. So if we have coupled structural walls in the building, then minimum thickness is 300 mm. So now minimum thickness requirement is defined for the structural walls in the initial paragraph. Of course, the requirement of fire resistance needs to be considered as per IS 456 in addition to this. Now, the same paragraph is mentioned here with a bit more detail. We can see here. Only if the bending moment diagram of vertical member is in a single curvature along the full height of the building, Even though with some jumps at levels where the beams and slabs frame into the wall, it should be treated as a structural wall. On the other hand, if it is in double curvature along the whole part of the height of the building, it shall be designed as a column. So what does it mean? That decision that let's say my element is acting as a structural wall or as a column, we will be able to determine only after performing, let's say, one iteration of the analysis. So if and software performing analysis, we need to see the bending moment diagram, and from that we have to take this judgment that whether the element is structural wall or column as per this clause. So according to me, few more sketches and details should be required, because here he said that even though with some jumps at levels where the beams and slabs and frame into walls, so wherever there is a beam and slab framing, so it is allowing certain jumps, and that should be treated as a structural wall. So what is a demarcation, when we will take a judgment when there is a jump? So what is the definition of those jump? So maybe I think a few diagrams are required, otherwise it may lead to practical difficulties, because we'll not be able to decide upfront in the structure system that this element is a structural wall or a column at let's say, without performing the analysis. And there may be a difference of opinion, because if this kind of statement is made that some jumps are allowed. So I think this is one of the major change I could see in the document. The shear force demand, those estimated as 1.4 times the design moment capacity, which is estimated as per 13.3.2.2. Actual force and bending moment capacity. Now here it says to consider the balance point as specified in IS 4556 for limit state design under load combinations not involving earthquake loads, and zero 0.4 FCK under load combinations involving earthquake loads. For the design moment capacity, the calculation is given here, or methodology is given here, and this is applicable, or rather we can say these are not applicable for the structural walls with boundary elements. So this methodology is given for structural walls without boundary elements. Shear force capacity. Okay, for the boundary element, the clauses are mentioned here. So when a beam frames into minor axis of the wall, then boundary elements shall be provided at such locations along the full height of the wall. The design of such a boundary element shall meet the requirements of minimum column dimensions perpendicular to the minor axis of the walls as given in 13.2.1, which is 20 dB, and minimum column to beam strength ratio as given in 13.2.2.4a. So here again, the concept of strong column, weak beam will be applied, which is, let's say, the column strength shall be at least 1.4 times larger than the beam strength. So basically, it will become, kind of a beam column arrangement at that location, wherever beams are framing in a minor direction in a structural wall. For opening in walls, it is said that the shear strength of a wall with opening should be checked at a critical horizontal planes passing through the openings, right? It also says about the additional steel reinforcement shall be provided, of course, along the four edges openings in the walls. Further, the area of this vertical and horizontal steel should be equal to that of the respective interrupted bars, provided half on the either side of the wall in each direction, and these vertical bars should extend for the full height of the story in which this opening is present, and the horizontal bars should be provided with development length in the tension beyond the edge of the opening. So here, some good detailing aspects are given here. For the coupling beams, whenever, let's say, coupling beams connect to the coplanar spatial structural walls, then they shall be classified either flexure controlled or, let's say, shear controlled, depending upon this ratio, LS by D. So if it's a flexural controlled coupling beams, then these beams shall be designed for the shear force demand in 13.1.2 and 13.1.3. And if it is a shear controlled coupling beams, then the methodology is given here. This is the coupling beam, which is critical in the shear. For the construction joint, it is said that the vertical reinforcement across a horizontal construction joint shall have area of steel, which we can define from this equation. For the ductile detailing, it is said that, of course, this is one of the good important point. I think this we were following in all the project, but now it is meant, it is made as a part of the draft document. When steel is provided in two layers, when we provide vertical steel in two layers, all vertical steel bars shall be contained within the horizontal steel bars. The horizontal steel bars shall form a closed core concrete area with closed loops and cross ties. So this is one of the good points mentioned in the document. Now, minimum reinforcement is identified in the RC structural walls, of course, with boundary element and with boundary element and without boundary element. The development length splices anchorage requirement is okay. Okay, it is said very clearly that welding is not permitted in any earthquake zone between reinforcing bars. And this is a good note. Welding shall not be permitted. Beam column and beam wall joints. So there is a, I think, paragraph called a distortional shear in the published standard, present standard right now. I think same clauses are mentioned here. Design of structure system, special moment frame. Now it is said that the special moment frame, resisting frames, may be used in any earthquake zones except in buildings taller than 15 meter in earthquake zones 4 and 5. And for any buildings having, let's say, importance factor values. Okay, values to be mentioned here, I think. So this restriction, again, it is in line with the draft document IS 1893 part 1 draft document. So, and yielding of beam column joints in SMRF is not permitted by this standard. I think this limit is quite stringent according to me. So this may be revisited, relooked according to me. Infill walls are permitted to be used in moment frame buildings. The effect of stiffness contributed by the infill shall be appropriately considered as per CD 39. Special moment frame buildings with special structural walls. So here it says that the yielding of beam column and beam wall joint in special moment resisting frame with special structural walls is not permitted by this standard. And in general, the yielding of beams supported on the weaker axis of a structural wall is not permitted. Still, I'm going through these specific requirements of structural walls, as well as, let's say, the additional requirement for individual system. But I'm just trying to highlight the quick points which I've just noticed while going through this document. For the structural configuration, also the points are mentioned here that. Okay, finally, additional criteria for the
steel buildings. As I said, for steel buildings, we had a number of sessions with reference to, let's say, ductile detailing of the steel structures. Quickly, I'll highlight few of the points here. The material is now updated in this standard. There is a concept called material strength uncertainty factor, RY and RU, and value is 1.4 and 1.2. So by this is the factor by which we will increase the strength for calculation of the capacity of different members. So there is a new concept of uncertainty factor added in the document. Of course, we have discussed with a lot of detail. If you are interested, you can watch our previous sessions on that. The limiting width to thickness ratios for compression elements of earthquake resistant structures. So what we just touched in the beginning of the session, that there is a requirement of smaller B by T and D by T ratio with reference to, let's say, current provisions of IS 800 2007. So this is the table. Then the slenderness ratio is also made relatively stringent in this document. If we see, for example, for the column, we can see that it is restricted to be less than 75 for all the columns as per this draft document. For bracing also, the important provisions are added, like how to design and detail out the connections for the bracing. Column to beam strength ratio is even, you can see, it could even go beyond the value of 1.4. In the IS 18168 2023, again, these are the same requirements there, but I think this requirement is very stringent. This needs to be revisited. Yeah, okay. And finally, there are so many clauses which are added here. And of course, we had several rounds of discussions on these similar types of clauses. So if you're interested, you can watch our previous recorded sessions on this document, or let's say on the ductile detailing of steel structures. Even when this draft document was getting prepared, at that time also we had 2 to 3 sessions, 2 to 3 live sessions. So you can watch those sessions also. And finally, in the last part of the document, we can see that the eccentric braced frame is added. All different frames are added. The detailed provisions are added for each frame, of course. And finally, this is the eccentrically braced frame, right? Okay, so with this, let's say we have quickly finished the discussion about part 1 and part 2. Okay, so what I'll suggest all of you to make your own observations in this 2 important documents, and please share your valuable comments to BIS Technical Committee before 3rd August 24, so that all the comments or let's say all your inputs can be considered while formulating these documents before they are published as a, let's say, design standards to be considered in the design. So thank you all very much. And you can write down in the comment box if you have any further specific queries, or let's say if there are any specific areas for which you want that live discussion should be organized, then please feel free to mention that also in the below chat box. Right. So with this, we are closing this session. Goodbye.